We have a digital mass airflow sensor. This demonstration serves for both the digital mass airflow and the digital manifold absolute pressure sensor. Both of them test out the same. I checked the wiring diagram, I probed into the signal wire, and now I'm looking at the scope here. Gonna have to go to about the lowest time increment that we deal with here in ENE2. But before I mess with time, I know it's way far out. I'm gonna get my voltage into spec. It's at 500 volt a division. That's way too long, so I'm gonna start taking it down towards millivolts. 100 volts, 50 volts a division, 20 volts a division, 10 volts a division, and let's see, we've got a little bit of deflection right there. You can see the voltage envelope that's starting to develop. So I'm gonna take that and continue to expand that. 2 volts a division here, 1 volt a division here. When that gray goes to black, it'll be ready to reset. Right there it is, it's black, and that is the voltage envelope we're dealing with. So I'm now going to take my time and start going down towards milliseconds. I can go pretty quick here to start with. At 500 milliseconds, it's still all shaded in. So I'm going to keep going. 200 milliseconds, 100 milliseconds, 50 milliseconds. No sign of any pattern there. It's just a completely shaded grayed envelope of where the voltage is at for this sensor. Continue to go down. I'm at 10 milliseconds, 5 milliseconds. I first start seeing some waveforms starting to develop. Continue to take it down. There's 2 milliseconds, 1 millisecond. Now I have a defined waveform, but I still want to get a better shot on that. So I'm going to go down into microseconds, and at 200 microseconds of division, I have a pretty good shot on this waveform. Right here is my trigger. If I highlight trigger, I can toggle. It'll catch the pattern going from positive to negative, or from negative to positive right there. Not a big deal on this sensor. I don't know why you'd want to use that, but that's the way the trigger works. You're going to need to know that for later on. Let's look at the difference between high airflow and low airflow. This right here, the engine's at idle. I'm going to have a snap throttle here. Go ahead and snap that throttle. Real aggressive, all the way down. There we go. With that snap throttle, you can see it tightens up quite a bit. Now, what I might want to do is measure frequency on this. So if I take my cursor, F4, turn it on, I can go to 2 vertical lines with F1. Now, I want to take, I'm over here, I'm going to take that and put that where the line goes up. Now I'm going to toggle over to this with F2. I'm going to move that over to a like spot on the pattern next to it. Right here it goes up, so the pattern's going up and the pattern's going up again. That's the frequency. I'm at 5.952 kilohertz right there. Now let's turn that off. Now we're back at idle here. I can now adjust this again, and I'm going to switch over here to my other. And I've got 2 kilohertz here at idle. So there you see the difference in high airflow and low airflow, or in the case of a manifold absolute pressure sensor, high air pressure and low air pressure is going to be an issue of frequency change.
Thank you, sir.